Hello everyone, this poster is about a scalable call graph constructor for Maven. As you know, nowadays software ecosystems are very popular. There is the use of third-party libraries for developers. Developers can easily fetch the dependencies from their servers and use them. However, this comes at a cost, and some of these libraries can be vulnerable, or they might have different kinds of problems. To mitigate this, there are some analyzers that aim to help the developers, but at the same time they are also not very accurate and they work at package level. There are some studies that show that fine-grained analysis or method level analysis can help such analyzers to perform better analysis, but the current existing tools to generate these fine-grained information are not scalable to be used in such scenarios. For example, current CG or call graph generators work with the full program, or they need a program together with all of its dependencies to be analyzed, but this approach is not very practical in such scenarios and can cause a lot of duplication when you want to analyze a dependency, or you want to analyze a lot of similar cases in a single ecosystem. In this poster, we propose an approach that untangles the dependency resolution from call graph generation and fix this redundancy problem. In this approach, we first download all of the packages from Maven Central. We create partial results for them and cache it in a storage. This partial information includes the call size of the packages and the class hierarchy of the packages, and after we store the dependencies or Python libraries in this cache, whenever we have a resolution and as a result we have a dependency set, we fetch these partial call graphs from this cache and stitch them together using the stitching algorithm that we have. This stitching algorithm walks through all call size of the packages, and based on the class hierarchy that it creates, it finds the correct targets for each source method. As you can see in the table, the proposed approach can improve the scalability and speed of the state-of-the-art call graph generator tool OPAL. We also showed another use case in this table, which is for commonly used dependency sets within a ecosystem. Once a dependency doesn't have any new dependency to be inserted in the cache and all of the dependencies are already processed, the analysis can be done even faster. To conclude, this work showed that incrementalization of call graph generation can highly improve the scalability of analysis. However, we plan to do more extensive experiments on Maven and show more tangible results on bigger sets of dependency sets. Thank you for listening.